Hi everyone, welcome. I'm going to be talking about Eclipse CDT and really talking about what its current state is with a lot of focus on LSP related parts of it. My name is Jonah Graham. I'm the project lead for the Eclipse CDT project, and I'm an open source advocate. I want everyone to use open source, and I help companies do that. So let's dive right in. Probably everyone in the room knows this, but this is also going to go on YouTube. So a quick overview of what CDT is. CDT stands for C and C++ development tooling. And it's the fully functional C and C++ IDE that lives on top of the Eclipse IDE platform. So it supports everything you'd expect an IDE to have in it. Creating projects, navigating your source, code editing, debug tools. So let's jump in and start talking about parsing C and C++ code. The CDT parser has been around for a long time now. The CDT project wrote a parser years ago because they needed a solution that was going to work for an IDE, not for compilation. Almost everything from that earlier slide depends on having a CDT parser in some way, if it's code completion, if it's source navigation, even many of the debug features. So while the CDT parser was once the best choice for how to implement it, it focuses on speed over accuracy even, and that's no longer a sufficient solution, because the main reason is that we supported all the standards really well until we stopped developing it actively. So there's very little support for the newest versions of C++. So if you're writing embedded software and you're targeting C code from 10, 15, 20 years ago, you're fine. But for modern stuff, it's just becoming less and less useful. Now, what that looks like to users is you open up your project, and your project is filled with red squiggly lines, and it doesn't make a great IDE if you can't then do all your source navigation, your finding, and stuff like that. So, I think it's been mentioned in a number of talks over this week so far. Language servers is the modern way to do this, and there's a specific one for C and C++ called clangd. Now, language servers provide a lot of those same features we saw at the beginning, source navigation, code editing, and clangd does that for C and C++. So it's part of the quite well-established LLVM project. The D on clangd is because it's part of the Clang project, the C front end for LLVM. So we're using the same parser with clangd as you might be using at the command line if you're using Clang instead of GCC. And so clangd supports a lot of the features you'd expect in an IDE. All your navigation, editing. It has some formatting features with Clang format. It generates all your error and warning markers as you might expect. Has some refactoring features and a number of other features. So why do we want to take an LSP for C and C++ and put that in the Eclipse IDE? So I think this is, as opposed to just saying, okay, everyone just go start using VS Code, it's already there, you don't need to do anything. And the reason is, I'm trying to explain by this slide. Now, this slide was put together about 7 years ago, and we did a quick ask of, all right, do you have a product that's based on Eclipse CDT? And in the first, couple of days, these are all the people who replied, says, yes, we have a product based on CDT. There's 28 of them there. I know that's not anywhere near all of them at the time, but this represents, millions of developer hours of added tooling. And many, if not all these projects, they're not just C and C++ IDEs. They have a lot of extra features. They have project wizards. They might have advanced GUIs for configuring the boards or generating device files or things like that. And they want to be able to keep using all those features, but still have good C and C++ editing support. So that's why we want to have LSP in the Eclipse IDE for C and C++. and we're going to leverage the best of the open source world. All right, so the CDT LSP project in its current iteration has been going on for a couple of years now. There has been attempts at CDT LSP for many years. We had a GSOC student do it about 4 or 5 years ago. But this is a reboot completely from scratch again, built on top of LSP4E. This is part of the Eclipse CDT project, so if you go to the Eclipse CDT organization GitHub, you can see it there. Gessa from Bachmann, I'm not sure that's the pronunciation, has been the technical lead on it. She's done the vast majority of the work on this. There are other individuals involved. Alaska, I think we have 10 different organizations that have contributed fixes within the Eclipse CDT specific part of the LSP support. The initial pre-release version we did in spring of 2023. It got added a 1.0 version a bit after that. It was added to Simrel sometime late last year, early this year. But critically, it got added into the Eclipse IDE for C and C++ developers download this summer in the OCX release. So the trying it out is a little bit easier. You just go download the IDE and change a preference, and then you're off and running. So I'm going to go through some basic features of the CDT LSP here. I got some more later in the presentation. But just so you can be confident that it looks like a C and C++ editor, so a little simple hello world project. You got some really nice hovers driven by clangd. Shows you that. You can hover over operators or anything. You get an outline, so you can navigate through your very complicated source code. I'm trying to remember what else is in this demo. Oh, you get refactoring, some amount of refactoring, a simple rename refactoring here that looks just like Eclipse, but is driven by clangd. So parsing is one big important part of it. Another big important part is building C and C++ projects. And just like the parser, we have some challenges in the Eclipse CDT project. Both the manage build, sometimes called manage make, and the core build parts of Eclipse CDT also have a lack of maintenance. They're both under resources and don't give the best user experience. Now, once again, the reason this matters is almost all those ISVs, they all have, they're all using these project builders, so they have some way of building. If we don't have a way of building the projects, we don't have a way of driving this whole system. And once again, we support all these older tools relatively well, the ones that were state-of-the-art when Eclipse CDT was under very active development. But our CMake support, for example, is quite terrible. I mean, out of the box. In fact, if you are doing CMake already, you probably are using CMake for Eclipse. If you haven't used CMake for Eclipse, go use CMake for Eclipse until CDT's core offering is brought up to speed better. Similar for Clang, we support GCC really well, call it command line options. And when Clang first came out, Clang and LVM knew, well, we better look at just like GCC because that gives our users the best results. But now that Clang is a mature project on its own, it obviously has its own options and its own workflows that need to be enabled. So the issue is, it's just not as good as it used to be a number of years ago. The expectations are different. We see project teams are often all want to use their different IDE. One's using C-Align, one's using VS Code, one wants to use Eclipse IDE because maybe that person in the team is a person who has to do some of the advanced debug and tracing features, so they do want to stay in Eclipse, whereas someone's just writing code, so they'd rather be VS Code. And if we're using manage make, sharing those projects is really hard. If they're using CMake on the build, then it's hard to use it in Eclipse in the other way. So that's why this is a growing issue now. So there have been some improvements to build support already, and there's more coming. So let's go over some that are either available or will be available in the coming. So I think we have most of everything I'm going to show immediately is coming in this Christmas release. And then we're expecting some big changes in the new year. So just a little thing, the fact that if you create a new CMake project in CDT and then hit debug, you would have no debug symbols by default, and that sucks, you know. So just, you know, the little change of when you're in debug mode, we build with debug to CMake. A tiny improvement, but an important one. All the LSP stuff that we showed before all needs some way of telling clangd what your includes are, what your sources are, what your compiler flags are. The normal way to communicate this information is with a compilation database, or it's called compile commands.json. That's the typical name for it. CMake generates this. There's a command line option to generate it for CMake. But all the people and all the installed user base with manage make, manage build need some way to do that. And we've had a contribution from Renesys this year that you can turn on either at the workspace level or at the individual project level, generating compile commands, and then when you build your project, you end up with your generate compile commands JSON, which clangd can then read. So then you can open the editor with clangd, and it will understand, where your includes are and what parts to enable and disable in your code. And then an additional important part of that is that we want to make sure that CDT LSP is picking up the correct compile commands.json. So the CDT LSP updates the clangd file automatically for you. So this project is in release mode as a build configuration, manage build, and open up the build configuration, change the active one to debug, and it'll update the clangd so that clangd will show you the right information based on the build configuration you're in. It becomes really important when you're dealing with multiple processors, which might have different sets of includes, that you get the right compilation database. Often between debug and release might not be a huge difference. All right, so I mentioned what our release plans a bit. So specifically, this is our current release plan. Our next major release, we're aiming to do that in February 2024. It's going to use the 24.12 as a target platform. And then very shortly after that, specifically if it's needed, we'll do a 12.1 release that targets that uses the target platform on that same day. So we have a bunch of fixes that have been going into CDT already onto the main branch, onto the CDT12 main branch, which are not breaking fixes, they're just bug fixes. So we're going to keep releasing CDT 11.x versions, at least until we get to CDT 12.1. So in fact, all the existing bug fixes that are on the main branch will be backported and released for 2024-12. There'll probably be CDT 6.2, 11.6.2, but the final version number is to be determined. So some of the highlights from that we expect in CDT 12, and these are going to be the disruptive changes. These are the breaking changes that are coming up. We're going to try to change some big defaults. This is probably the main reason we need a major change, more than API breaks even. We're going to try and make it so that projects which are targeting modern tool chains like C++, 17 and newer, we use the CDT LSP editors by default rather than the traditional, rather than the old C editors. Now, we're not planning to get rid of any of the old editors, or the old parser. That's going to be there for years to come, but certainly not we're not looking at deprecating that anytime soon. There's a lot of stuff that depends on it, but we're not planning to really fix it either. We're not planning to add new language support to the old parsers. If someone wants to come along and improve them, they would be welcome to. I'm just not sure it's going to happen. I think it's probably not an investment worth making at the moment. If you have an existing project and you upgrade your Eclipse, we're going to keep you in the same tool flow as before. If you had a project working in CDT 11 and you upgraded to CDT 12, we don't want to open a new editor, have a whole new look and feel, and break you. So existing projects will stick in there. But we are going to try to put in some notifications to users to make it easier for them to discover that there is this new feature. Because if you just go download the latest version of Eclipse CDT, even the one with CDT LSP in it, you wouldn't know it's there unless you went looking in the new and noteworthy or the preferences. So one of the ways, I'll talk a bit more about that later, but is just some quick fixes and maybe notifications so that users know that. So the other area that's going to get a big update for CDT 12 is core build. Simple goal, just make CMake work. Make sure it interacts with other things. While CMake support with core build, that's just an Eclipse you download from open source, isn't great. The CMake that vendors like Renesas have actually looks pretty good. They've done a bunch of improvements, and we're just working now on getting those open sourced and made general purpose rather than Renesas specific. If you're an ISV yourself, you're probably going to be affected by some breaking changes in core build if you're using core build. So keep a look at follow along with the changelog API so you know where those breakages are, and follow along the new and noteworthy as the changes are introduced so you can see what's changing ahead of the release and be ready for the release. All right, so CDT LSP is still pretty new. So the other thing I want to do here is just kind of promote a bit of what CDT LSP looks like for end users so that they are happy to have this new feature. One of the important features, because I expect we have ISVs more likely in this room than end users, but is that we want to make sure that CDT LSP is very configurable for ISVs. Almost all of the enablements of CDT LSP are controllable by vendors. So the way you turn on CDT LSP is you just check this one checkbox, maybe in your workspace or per project, and then you'll have the LSP editor being used by default when you click on C++ files. Not everyone wants to show that. People want to have that defaulted on, defaulted off, or any other combination. You can go even further and configure that per project. So if you have a project that's targeting an older tool chain that you know works well with CDT and also has other features that rely on having the full parser running, you want to make sure that users aren't accidentally turning this on. So you might disable LSP for that. Or vice versa. You have a project that you know absolutely needs it, and the user's experience will be terrible if they don't have clangd version running. You can do that. You can actually change the backend implementation. You have your own clangd version that you need to support for some reason. Like maybe you have some extensions to Clang that you need to push out there. You can change the defaults. So there's a lot of features to help ISVs in that place. A key part of the development of CDT LSP is making sure that CDT LSP source code base itself only has stuff which is CDT specific. CDT LSP builds on top of LSP4E. So wherever possible, if something can live in LSP4E code base, that's where the fixes went, not into CDT's one. So just a simple example, I can't remember exactly which part of type hierarchy, I think it was the quick type hierarchy, needed some changes in LSP4E, so that's where the fixes went rather than into CDT itself. So here's a couple of screenshots showing what type hierarchy looks like for in C++. Similarly, supporting files outside of the workspace in C and C++ is much more important than in many other languages. So if you're working in JavaScript, everything's in your work tree. It's either known modules or it's in your source itself. With C++, you have header files. Those header files normally live in user include or some specific place that's outside your workspace. So making sure all that works is important. So some fixes have been put into LSP4E to make sure that that's there. As I mentioned already, LSP4E is the basis for CDT, but so is TM4E, Eclipse Platform's generic code editor. So some of the preferences that you need to actually configure CDT LSP actually come from the LSP4E and TM4E preferences. So I've just highlighted some of them here. We try to highlight when you go to the CDT LSP's preferences, click around, we put links to the other preferences so that users can actually find them. Some other key features that might, they're important. So it's really important that we support multiple tool chains for the same workspace. I think this one's a video, yeah. So here we have two projects. The bottom one uses an ARM tool chain. The top one's just using your local GCC. So you can see here, we just set the tool chain to the ARM Linux tool chain. This one's using the default tool chain. So when we click on anything here, so we open cout, you can see that the path for this is the user ARM Linux one. But if you go to the normal Hello World project and cout, it's just in user include. So clangd does understand, clangd and CDT LSP all make sure they understand this and have the right header files for the right projects that open up. Quick fixes are an important part of the IDE ecosystem, and clangd has a whole bunch of quick fixes, and we're fortunate because of all the infrastructure that came before us. This just works. So we have here a syntax error of sorts that clangd knows how to fix, and it inserts the brackets for you. And the video is just restarting there to fix it. Oh, so I already showed briefly what the hierarchy looked like as a screenshot. I have a little video here. Now, this project is the full LLVM code base, so you can see some of the speeds, especially when we get to the call hierarchy in a second. So there's a type hierarchy, so it works as quickly as you'd hope. When we talk about speed, it's not as fast in all cases as the CDT indexer. The CDT indexer and parser was written for speed over accuracy, and that means that it will index your code faster than clangd might. Some other features, like I forgot that was in this video, that just changing between source and headers is another important thing for CDT. So what are the next steps for CDT LSP? So there are a bunch of improvements still to be made. The first one is discoverability. If the users don't know this exists, they're going to abandon CDT, and that's not ideal. So we're going to be adding some quick fixes so that if there's an error, like if you hit a parsing error, one of the quick fixes should be in CDT 12, hey, do you want to try CDT LSP? Change this project to CDT LSP, reopen this file with the CDT LSP editor. We're going to, the other discoverability, we're going to make new projects using CDT LSP and put some first-time notifications in there. We're also going to try to make sure it's easy to switch back. We want a user to try out CDT LSP, but if it doesn't work in their use case, we don't want to then leave them with a broken setup. Now, the theme, if anyone's used CDT before, CDT has its own look and feel. It's one of the things that makes Eclipse maybe a little bit unusual, and that is certainly all the earlier languages that were supported by Eclipse, and C++ was pretty much the first one after Java. Ends up doing a lot of the colors and look and feel themselves. But CDT LSP sits on top of the TM4E and LSP4E and generic code editors. So all of the look and feel comes from those projects. We have already had bug reports with like some of why is this changed? Why does it look like this? We want it to look like we would expect. So there's still an open question: is do we need to have an ability to make CDT look like it? Do we do that by having some themes that we contribute back to TM4E and LSP4E? I can't remember exactly which parts go where, so that it can look a bit more like how CDT users expect. It's an open question still. AST access. So this is kind of a big open question of how to handle it. One of the really powerful things for how CDT works is the AST for files are exposed to any plugin that wants to access them. Anything can search for symbols and get back into the AST and do all sorts of clever stuff. kind of clever stuff is like advanced help, advanced hovers. Some really neat things are related to code compliance, built on top of frameworks like Codan, which all requires AST access. Now, CDT LSP does expose a clangd feature, which is the AST. So this is an extension to the language server protocol. It's not part of the standard LSP. But we have some open questions. Do we need to provide a migration path? So I find it really interesting watching the talk about Java-C in JDT, where they're taking the Java-C information and then they're converting it to the DOM, I think, if I understand well, of JDT. So then all the JDT features can still work like they used to. Are we going to need a path like that for CDT LSP? And the first question is the AST that we get from clangd sufficient to even do that? Right now, the indication is it might not be sufficient. Some of the people who've tried it out already have found that it just really wasn't fit for the purposes that the CDT AST was. But the good news is that they also found that the symbol information that LSP provides actually covers the vast majority of the use cases that they really wanted. You know, when you break it down, it's like, well, yeah, having the full AST is nice, but symbol information from LSP can give you almost all the information you wanted anyway. One of our contributors wrote up a really nice comment in relation to this. I link it there so you can go read more about it if you have to do some of that integration work. So this is almost related to the discoverability and things, but it's like, how do users get clangd? Traditionally, if you go download CDT now from eclipse.org, you are not going to have any tool chains. You're not going to have any make. You have to go deal with all of that yourself. ISVs, fortunately, handle that normally. If you get an installer from someone like Renesas, it will install all of the tools that you might need so that you can actually get up and running. So where does clangd fall in that? Do we include clangd? I mean, Eclipse didn't have Java bundled with it for most of Eclipse existence. I mean, that's a fairly new feature. So, excuse me. It's just reminding me that I have a M2 to build today. So, you know, the question is, you know, should we include clangd? I think VS Code tries to see if clangd is there. It'll prompt you, say, hey, you don't have clangd. You want me to download and install that for you? I'm like, well, actually, yes. So something like that is going to probably be needed. And hopefully, if we do it, it'll be done by CDT 12 so that users can have a good experience. All right. So in conclusion, CDT has a long history. And to make it useful going forward, we're just going to have to leverage the open source ecosystem that's wider than CDT is. There's a lot of tooling based on CDT. That's why we want to keep it alive and keep it going. And the main open source features that we want to leverage are LSP, clangd, CMake, because they are all going to enable CDT to be relevant going forward and hopefully make our CDT users happy. All right, so thank you very much for coming to my talk on the reality of CDT. And if you have any questions, I'd be happy to answer them now. All right, well, I'll go have lunch, and you can grab me around the conference if you need. Thanks.